I connect with a BNB testnet wallet. That wallet is the identity for my autonomous agent. I choose the household role. The dashboard summarizes pantry risk, budgets, and upcoming carts. I'll jump into the household workspace to configure pantry and guardrails. In the pantry, I record reality: 1.5 kilos of coffee beans, used at 0.1 kilograms per day, approximately 15 days left, and 3 cartons of oat milk at 0.75 cartons per day, approximately 4 days left. We store everything in convex and compute days left equals quantity divided by average daily use, then classify each item as comfortable, watch, or critical. That's the signal for our Aikido style auto cart. Here I set Aikido style guardrails, a $120 weekly budget, and auto approval for carts up to $45. I allow Amazon and Walmart as vendors. These match the Aikido bounty framing: grocery only, vendor allow lists, no hard-coded orders. All of this is persisted in convex and used downstream to gate the agent's behavior. Based on pantry risk and those caps, the agent proposes a cart: 4 cartons of oat milk from Walmart for about $32, comfortably under the $45 cap. Since Amazon and Walmart's production APIs are gated behind real sales and long reviews, the Aikido mentors explicitly allow high-fidelity simulation mode. I approve the cart, we log it in convex with status, simulated. In settings, I define global caps and execution policy for the BNB chain pieces of the system. I keep the preferred network on BNB testnet, cap any premium request at $300, and any on-chain transaction at $75. I enable transaction warnings and allow deny lists, and only allow our own registry and service token contracts. These policies are enforced before any X402 style execution in the Copilot, keeping the Quack Times Chain GPT agent safe and fitting the testnet/mainnet toggle requirement. Now I log in as a farmer. This switches my profile and dashboard to the farmer workspace. From the farmer dashboard, I click Run Climate Simulation to open the field planner. This example field is 8 hectares of corn in the US Midwest, around latitude 42, longitude -93. When I run the simulation, our backend calls NASA Power's Temporal Daily API with community equals AG, the Agroclimatology Archive. NASA's docs explicitly describe this community as providing daily solar and meteorological parameters to support agricultural decision support tools. We aggregate the daily data into mean temperature, total rainfall, and the number of drought days, and compute a drought risk label. We store the result in convex per wallet and field and reflect it back on the farmer dashboard as the yield outlook. That's how we address the Space Agri track, a real AI agriculture agent. Now we switch to the Chain GPT Copilot. In the Research tab, I ask about the security and UX trade-offs of granting unlimited approvals to my own service token on BNB testnet. We call Chain GPT's Web3 LLM, which the docs describe as the single endpoint for chat completions. The answer is crypto native, explaining allowance risks and safe patterns. On the Audit tab, I send my agent registry contract address to Chain GPT's Smart Contract Auditor model, again via /chat/stream, but with the auditor model configured. The API returns a human-readable audit report describing any potential access control or upgradability issues. Using Chain GPT both for research and audits, 2 distinct APIs, is precisely what the Quack X Chain GPT Super Web3 agent bounty expects. In execute mode, we demonstrate a 402 style payment negotiation for registering an agent on BNB. I choose the register agent action with agent ID Farmer Corn Iowa. On the first execute, our gateway responds with HTTP 402 payment required and a structured payment description for a small amount of our service token, closely following the X402 specification that uses HTTP 402 to negotiate on-chain payments for APIs and content. The UI renders that as a paywall. When I confirm, the client signs the provided EIP 712 witness with my wallet and resubmits the request. The gateway verifies policy, caps and contract allow lists from settings, and then simulates or sends the transaction on BNB testnet, returning a TX hash. Alongside the web app, we run Field2Fridge ASI, a UAgent built with Fetch.ai's UAgents framework. This agent uses the agent chat protocol so it can understand natural language and interoperate across Agentverse and ASI1. Field2Fridge ASI exposes a simple REST endpoint /cart_decision via UAgent's REST integration. When I POST a simulated approval, wallet 0xABCD, Walmart $32, the agent logs the decision and returns an acknowledgement. When the household agent approves a real card in the UI, we also forward that decision to the Field2Fridge ASI UAgent. That means the UAgent can perceive real household events, use ASI1 Mini for higher level reasoning, and coordinate with other agents in the ASI ecosystem through Agentverse. This is how we satisfy the ASI/fetch/Agentverse track, a UAgent built with UAgents, powered by ASI1, integrated with our broader Web3 and NASA-powered system